Sample Project Specification for Pipeline SCADA System. Section 1, Introduction. System Description. The SCADA system includes MCC, SMCC LCC RTUs and SIS for monitoring and control of the pipeline and facilities. Key features: redundant Ethernet LAN, hierarchical configuration, and 99.9% system availability. Section 2, Scope of Work, Seller Scope. Design, supply, installation, testing, and training for the SCADA system. Owner facilities, power supply, communication links, and office facilities. General requirements, environmental conditions, interface points, spare capacity, and compliance with standards. Section 3, System Features. Hardware, dual redundant servers, operator workstations, database redundancy, and engineering workstations. Software, SCADA displays, alarm management, data processing reports, historical storage, and system security. Section 4, Specific Functional Requirements. Start-end of production day, time synchronization and time reference. Supervisory control, control commands verification and select verify command procedure. Automatic dial-up alert, notification of events or alarms. RTU communications, communication statistics, and performance monitoring. Section 5, RTUs. Design requirements. Advanced Intelligent Device for integrated control, supporting multiple protocols and Ethernet ports. Performance, scanning times and time-stamped inputs. Services included configuration, programming, and diagnostics. Construction and wiring, suitable enclosures, labeling, and earthing. Section 6, Field Marshalling Cabinets. General, supply of field marshalling cubicles and internal wiring. Construction, modular panels with air-dried epoxy paint. Identification and termination, clear labeling and wiring standards. Power supply and ventilation, reliable power and proper ventilation. Section 7, System Software. Software for all specified functions and future extensions. Database software interfaces, real-time and historical databases. Control and logic functions, standard configurable functions. Diagnostics, monitoring system health and resource utilization. Section 8, Pipeline Applications. Configuration, dedicated PaaS platform linked via high-speed Ethernet. Integration with SCADA, operator interface, system logging, data display, and results handling. Section 9, Communications. Internal communications, fast Ethernet LAN. Networking, dual Ethernet switches and routers, SNMP client utilities. RTU communications, TCP/IP network links with multiple serial communication links. Firewall, dedicated firewall for external connections, protecting against unauthorized access. Section 10, System Performance. Operating performance, continuous operation under different loading conditions. Operator interface, response times for control actions and status changes. Availability and MTBF, calculations for system availability and fault rectification. Section 11, Contract Procedures and Control. Program of Work, detailed contract program and quality plan. Progress monitoring, monthly reports on activity status. Subsellers, approval required before subcontracting. Section 12, Inspection and Testing. General, inspection during manufacture and on-site. Factory acceptance testing, FAT. Detailed test schedules and continuous run tests. Commissioning, site acceptance tests and ongoing support. Section 13, Delivery. Shipping breaks, information on shipping breaks and protection measures. Section 14, Installation. Responsibilities, transportation, lifting, unloading, and installation of SCADA equipment. Section 15, Training Requirements, General. Comprehensive training for engineering, maintenance, and operations staff. Specific trainings, operations, maintenance, programming, and PaaS simulation system training. Section 16, Documentation. Language and units, documents in English using SI units. Drawing and information schedule, schedule of drawings and information for approval. Operating and maintenance manuals, comprehensive manuals for all equipment. Section 17, Maintenance Contract Option. Maintenance, covering hardware, software, communications, display updates, database changes, and RTU configuration for 3 years. This sample project specification provides a comprehensive framework for the design, installation, and operation of a SCADA system for pipeline monitoring and control, ensuring reliability, efficiency, and safety. Section 1. Introduction 1. System Description. The SCADA system is designed to provide safe and efficient operation of the pipeline and facilities with minimal manned intervention. It includes various components such as MCC, SMCC, LCC, RTUs, and SIS. 1.1 MCC, SMCC, and LCC. MCC Master Control Center, located at Jamnagar, it monitors the entire pipeline system. SMCC Submaster Control Center, located at Bhopal, acts as a backup for MCC. LCC Local Control Centers, installed at various manned stations along the pipeline for local monitoring and control. Key features: dual redundant Ethernet LAN and open systems architecture. Hierarchical configuration, ensuring local control by LCCs even if MCC and SMCC fail. Communication with Marketing Terminal Tank Farm Management System, TFMS, via dual serial links or Ethernet. 99.9% or better system availability. Expansion capability for future unmanned pump stations and additional monitoring facilities. Section 2. Scope of Work. 2.1 Seller Scope of Work. Design and Supply. Complete SCADA system including hardware, software, RTUs, and necessary integration with existing systems. Installation. Set up and commission the system at specified locations. Testing and validation. Conduct factory acceptance tests, FAT, and site acceptance tests, SAT. Training. Provide training for operators and support engineers. HAC 2.2 facilities to be provided by the owner. Power supply. Stable and reliable power source. Environmental conditions. Suitable infrastructure to maintain specified environmental conditions for the equipment. Communication links. Necessary communication infrastructure for the SCADA system. Office facilities. Workspace for seller's personnel during installation and commissioning phases. HAVR 2.3 General Requirements. Power supply. Ensure uninterrupted power with backup facilities. Environmental conditions. Maintain specified temperature and humidity levels. Interface points. Define and provide necessary interface points for system integration. System spare capacity and spares. Maintain spare capacity for future expansion and provide necessary spare parts. Consumable parts. Ensure availability of consumable parts for maintenance. Glass fibers and asbestos. Avoid the use of these materials in the equipment. Gases and fumes. Ensure proper ventilation and handling of hazardous gases and fumes. Flammable materials. Follow safety protocols for handling flammable materials. Radio interference. Ensure equipment is immune to radio interference. Standardization of equipment. Use standardized equipment to ensure compatibility and ease of maintenance. Y2K compliance. Ensure all systems are Y2K compliant. Section 3. System features. 3.1 Hardware. 3.1.1 SCADA Master Station Servers. Dual redundant servers. Ensure high availability and reliability. Database redundancy. Options for maintaining up-to-date database copies. 3.1.2 Operator Workstations. Multiple operator workstations. Provide intuitive and easy-to-use interfaces for operators. 3.1.3 Integration of MCC and LCC control stations. Integration at Jamnagar and Bhopal. Seamless control and monitoring across different stations. 3.14 Database redundancy options. Real-time synchronization between MCC and SMCC databases. 3.1.5 Dynamic wall mimic panels. Large rear projection screen displays for better visualization of system operations. 3.116 Printers. High-speed printers for printing reports and logs. 3.17 Web-based MMI. Web-based MMI access for remote monitoring and control using standard web browsers. 3.18 Engineering Workstations. Engineering workstations for system configuration, programming, and testing. 3.1.9 System Expansion. Scalable architecture. Allows for future system expansions. 3.2 Software. 3.2.1 SCADA displays. Graphical displays for real-time monitoring and control. Alarm displays segregated from other SCADA alarms for clarity. Batch tracking displays for monitoring batch processes. Leak detection displays for identifying and locating leaks. 3.2.2 Alarm philosophy. Comprehensive alarm management to ensure timely detection and response to system anomalies. 3.2.3 Alarm and event management software. Detailed logging of all alarms and events for future analysis and reporting. 3.4 Data processing reports and logs. Report generation for various operational and historical data. Log management for maintaining records of all significant events. 3.2.5 Historical storage and archiving. Data archiving using hard disks and CDRW disks for long-term storage. 3.2.6 Engineering facilities. Engineering tools for system configuration, troubleshooting, and maintenance. 3.2.7 System security requirements. Access management, multiple access levels for different user roles. Audit logging, tracking all commands and changes made in the system. 3.2.8 Audit logging of commands, detailed logs, including date, time, command executed, operator identity, etc. 3.2.9 Failover philosophy, redundant systems, ensuring continuous operation in case of hardware or software failures. Automatic failover between primary and backup systems. Section 1. Introduction 1. System description. The SCADA system is designed to provide safe and efficient operation of the pipeline and facilities with minimal manned intervention. It includes various components such as MCC, SMCC, LCC, RTUs, and SIS. 1.1 MCC, SMCC, and LCC. MCC Master Control Center, located at Jamnagar, it monitors the entire pipeline system. SMCC Submaster Control Center, located at Bhopal, acts as a backup for MCC. LCC Local Control Centers, installed at various manned stations along the pipeline for local monitoring and control. Key features: dual redundant Ethernet LAN and open systems architecture. Hierarchical configuration, ensuring local control by LCCs even if MCC and SMCC fail. Communication with Marketing Terminal Tank Farm Management System, TFMS, via dual serial links or Ethernet. 99.9% or better system availability. Expansion capability for future unmanned pump stations and additional monitoring facilities. Section 2. Scope of work. 2.1 Seller Scope of Work. Design and supply. Complete SCADA system including hardware, software, RTUs, and necessary integration with existing systems. Installation. Set up and commission the system at specified locations. Testing and validation. Conduct factory acceptance tests, FAT, and site acceptance tests, SAT. Training. Provide training for operators and support engineers. HAC 2.2 facilities to be provided by the owner. Power supply. Stable and reliable power source. Environmental conditions. Suitable infrastructure to maintain specified environmental conditions for the equipment. Communication links. Necessary communication infrastructure for the SCADA system. Office facilities. Workspace for seller's personnel during installation and commissioning phases. HAVR 2.3 General Requirements. Power supply. Ensure uninterrupted power with backup facilities. Environmental conditions. Maintain specified temperature and humidity levels. Interface points. Define and provide necessary interface points for system integration. System spare capacity and spares. Maintain spare capacity for future expansion and provide necessary spare parts. Consumable parts. Ensure availability of consumable parts for maintenance. Glass fibers and asbestos. Avoid the use of these materials in the equipment. Gases and fumes. Ensure proper ventilation and handling of hazardous gases and fumes. Flammable materials. Follow safety protocols for handling flammable materials. Radio interference. Ensure equipment is immune to radio interference. Standardization of equipment. Use standardized equipment to ensure compatibility and ease of maintenance. Y2K compliance. Ensure all systems are Y2K compliant. Section 3. System features. 3.1 Hardware. 3.1.1 SCADA Master Station Servers. Dual redundant servers. Ensure high availability and reliability. Database redundancy. Options for maintaining up-to-date database copies. 3.1.2 Operator Workstations. Multiple operator workstations. Provide intuitive and easy-to-use interfaces for operators. 3.1.3 Integration of MCC and LCC control stations. Integration at Jamnagar and Bhopal. Seamless control and monitoring across different stations. 3.14 Database redundancy options. Real-time synchronization between MCC and SMCC databases. 3.1.5 Dynamic wall mimic panels. Large rear projection screen displays for better visualization of system operations. 3.116 Printers. High-speed printers for printing reports and logs. 3.17 Web-based MMI. Web-based MMI access for remote monitoring and control using standard web browsers. 3.18 Engineering workstations. Engineering workstations for system configuration, programming, and testing. 3.1.9 System Expansion, Scalable Architecture, allows for future system expansions. 3.2 Software. 3.2.1 SCADA Displays, graphical displays for real-time monitoring and control. Alarm displays, segregated from other SCADA alarms for clarity. Batch tracking displays, for monitoring batch processes. Leak detection displays, for identifying and locating leaks. 3.2.2 Alarm Philosophy, comprehensive alarm management to ensure timely detection and response to system anomalies. 3.2.3 Alarm and Event Management Software, detailed logging of all alarms and events for future analysis and reporting. 3.4 Data Processing Reports and Logs, report generation, for various operational and historical data. Log Management, for maintaining records of all significant events. 3.2.5 Historical Storage and Archiving, data archiving using hard disks and CDR-W disks for long-term storage. 3.2.6 Engineering Facilities, engineering tools for system configuration, troubleshooting, and maintenance. 3.2.7 System Security Requirements, access management, multiple access levels for different user roles. Audit logging, tracking all commands and changes made in the system. 3.2.8 Audit logging of commands, detailed logs, including date, time, command executed, operator identity, etc. 3.2.9 Failover Philosophy, redundant systems, ensuring continuous operation in case of hardware or software failures. Automatic failover between primary and backup systems. Section 4. Specific Functional Requirements. 4.1 Start-End of Production Day. The SCADA Master Station shall operate under a concept of a start and end of production day, configurable designated time within the Master Station setup. This designated time shall be the reference for all equipment and software throughout the SCADA system. The MCC shall be the authoritative source of time for the SCADA system. All time reference calculations and processing tasks shall use this time to start and end hourly, daily, weekly, monthly, and yearly calculations. Now to 4.2, Time Synchronization and Time Reference. The time used by the MCC shall be referenced to a GPS interface connected directly to the MCC. The MCC shall regularly send time synchronization messages to all microprocessor-based attached equipment within the SCADA system. Intelligent field instrumentation devices do not require time synchronization unless the facility already exists within the device. Time synchronization messages shall be sent to interconnected equipment in advance of the start-end of day time to avoid communication loading congestion. 4.3 Supervisory Control. The operator interface shall transmit control commands to the RTUs and verify the success of the control action. A defined time period for a field device to confirm the control action shall be set in the database. An in-transit state should be displayed to show the operator that control is in progress. Invalid control requests shall be rejected by the SCADA system master station. The system shall use a true select verify command control procedure to prevent undesired commands. 4.4 Automatic Dial-Up Alert. In case of an event or alarm, the system shall automatically dial up and alert the designated personnel. The alert system shall ensure immediate notification of the event to the responsible parties. 4.5 RTU Communications and Monitoring. 4.5.1 RTU Communication Statistics. The system shall maintain statistics on RTU communications to monitor and evaluate performance. Statistics shall include data on the number of successful and unsuccessful communication attempts, retries, and any errors encountered. 4.6 Pipeline Metering. The system shall support accurate pipeline metering to monitor the flow of hydrocarbons. The metering system shall integrate with the SCADA for real-time data collection and analysis. 4.7 I/O Points. The system shall support a comprehensive range of I/O points, including analog and digital inputs and outputs. The I/O points shall be configured to monitor and control various aspects of the pipeline and associated equipment. 4.8 Cathodic Protection Monitoring and Reporting. 4.8.1 Pipeline Cathodic Protection Data Display. The SCADA system shall monitor and report on the cathodic protection status of the pipeline. Real-time data on cathodic protection levels shall be displayed and logged for analysis. 4.9 Safety Instrumented System, SIS. 4.9.1 SIS SCADA Overview. The SCADA system shall integrate with the Safety Instrumented System to ensure safe operation of the pipeline. The SIS shall monitor critical safety parameters and take necessary actions to prevent hazardous conditions. 4.92 SIS SCADA Functionality. The system shall provide functionalities such as emergency shutdown, ESD, safety interlocks, and alarm handling. 4.93 SIS SCADA Operator Interface. The operator interface shall display safety-related information and allow control of SIS functions. 4.9.4 Station ESD Condition. The system shall handle emergency shutdown, ESD conditions by coordinating with the safely shut down the affected sections of the pipeline. 4.9 Information System Interface. The SCADA system shall interface with the Management Information System, MIS, to provide operational data and reports for management purposes. 4.11 Terminal Tank Farm Management System, TFMS, Interface. The SCADA system shall interface with the Terminal Tank Farm Management System to manage and control tank farm operations. Dual Redundant Serial Interface Links, or Gateway Running TCP/IP, shall be used for communication between LCC and TFMS. #4.12 RTU Logic Sequence Control. The RTUs shall support logic sequence control for various operational scenarios. 4.12.1 Move Control. Motor-operated valves, MOVs, shall be controlled through the RTU logic sequence. 4.12.2 Tank Inlet Manifold Control Logic. Control logic for tank inlet manifold operations shall be implemented in the RTUs. 4.12.3 Booster Pump Operation. Booster pump operations shall be controlled and monitored through RTU logic. 4.12.4 Separator Filter Station. Control logic for separator filter stations shall be managed by the RTUs. 4.12.5 Turbine Meter Run Control. The RTUs shall control turbine meter runs for accurate flow measurement. 4.12.6 Master Meter and Meter Prover. The system shall manage master meter and meter prover operations through RTU logic. 4.12.7 Mainline Pump, VSD Control. Variable Speed Drive, VSD control for mainline pumps shall be implemented in the RTUs. 4.12.8 Inlet Scraper Station, PIG Receiver. The system shall manage PIG receiver operations at inlet scraper stations. 4.12.9 Outlet Scraper Station, PIG Launcher. PIG launcher operations at outlet scraper stations shall be controlled through the RTUs. 4.12 Delivery Station Manifold Control. Control logic for delivery station manifold operations shall be managed by the RTUs. 4.12.11 Batch Tracking Control. The system shall support batch tracking control for pipeline operations. 4.12.12 Batch Switching. The RTUs shall handle batch switching operations to ensure smooth transitions between different batches. 4.12 Pressure Flow Control. Pressure and flow control operations shall be managed by the RTUs. 4.12.14 Sump Pump Monitoring. The system shall monitor sump pump operations and provide necessary controls. 4.12.15 Pump Condition Monitoring Interface. The SCADA system shall interface with pump condition monitoring systems to ensure optimal performance. STARS 4.12.16 Pipeline Startup and Shutdown Sequence Logic. The RTUs shall manage the startup and shutdown sequence logic for safe and efficient pipeline operations. 4.13 Density Compensation. The SCADA system shall support density compensation for accurate flow measurement and control. These sections provide a comprehensive overview of the specific functional requirements for the SCADA system, ensuring safe, efficient, and reliable operation of the pipeline and associated facilities.